There is a mechanism inside your toilet tank right now that releases approximately 3.5 to 7 gallons of water every single time you flush. That volume was standardized in the 1980s before water conservation became a regulatory priority, and older toilets installed before 1994 can use up to 7 gallons per flush compared to the 1.6 gallons required by federal law for toilets manufactured after that date. But even if you have a newer low-flow toilet, there is a simple adjustment you can make inside the tank using materials you already own that reduces flush volume by 30 to 40% without affecting waste removal performance in any noticeable way. This modification costs exactly $0, takes less than 5 minutes to implement, and can cut your household water consumption by 15 to 25%, depending on how many people live in your home and how many times toilets are flushed daily. For the average American family of 4, flushing approximately 28 times per day total, this single change saves between 8,000 and 12,000 gallons of water annually, translating to $40 to $70 in reduced water and sewer charges depending on your local utility rates. And the reason plumbers never mention this during service calls is because a population maintaining maximum flush volumes generates more frequent clogs, more service calls for running toilets and faulty flappers worn out by excessive water flow, and more premature replacements of fill valves and flush mechanisms degraded by unnecessarily high cycle volumes. Right now, lift the lid off your toilet tank and look inside. You will see several components. A fill valve on the left side that controls water entering the tank. A flush valve in the center with a rubber flapper that releases water into the bowl when you press the handle. A float mechanism, either a ball on an arm or a cylindrical float sliding on the fill valve shaft that rises with water level and shuts off the fill valve when the tank is full. That float position determines how much water the tank holds and consequently how much water releases with each flush. Factory settings position the float to fill the tank to a level approximately 1 inch below the top of the overflow tube, maximizing flush volume to ensure waste removal under all conditions. But most residential waste removal requires far less water than this maximum volume provides. By lowering the float position and reducing tank water level by 1 to 2 inches, you reduce flush volume proportionally while maintaining adequate pressure and flow for effective waste clearing in typical usage. Let us go back to why toilets use so much water and how flush volume standards evolved over time. Early 20th century toilets used gravity flush systems similar to modern designs but with no volume restrictions. Tanks held whatever amount manufacturers chose, typically 5 to 8 gallons. Flush performance was never an issue because overwhelming water volume compensated for any deficiencies in bowl design or drain configuration. As urban water systems expanded and treatment costs increased, municipalities began recognizing that toilet flushing represented the largest single category of indoor residential water use, accounting for 30 to 40% of total household consumption. Reducing flush volumes became a conservation priority. Federal legislation in 1992 established a maximum flush volume of 1.6 gallons for all new toilets sold in the United States. Manufacturers redesigned bowls and flush valves to work within this constraint. Modern low-flow toilets perform adequately at 1.6 gallons because the entire system is engineered around that volume. But millions of older toilets installed before this standard remain in use, and even newer toilets often fill tanks beyond what is actually necessary for reliable flushing. The reason is manufacturer liability protection. Companies set fill levels high to minimize any possibility of inadequate flush performance that could generate complaints or warranty claims. They prioritize zero flush failures over water efficiency because a customer experiencing a failed flush blames the toilet, while a customer using excess water blames nothing because they never see the waste. This asymmetry drives conservative engineering that favors excessive volume. The result is toilets flushing 3 to 5 gallons when 2 to 3 would work equally well for 95% of usage. This has been confirmed through testing and real-world implementation. Water conservation programs in drought-prone regions, including California and Nevada, have promoted toilet tank displacement methods for decades as interim measures before full toilet replacement. These programs provide detailed instructions for reducing flush volume using tank inserts, weighted bottles, or float adjustments. Studies measuring flush performance after volume reduction consistently show that reducing flush volume by 30 to 40% maintains adequate waste removal for typical solid and liquid waste while dramatically cutting water consumption. Occasional heavy waste loads may require a second flush, but even accounting for this, total water usage drops significantly compared to single high-volume flushes for every use. But here is where the economics become uncomfortable for the plumbing industry. A household that reduces per flush volume by 1 gallon saves approximately 7,000 gallons annually, assuming 25 flushes daily. At typical combined water and sewer rates of $6 to $10 per thousand gallons, that equals $42 to $70 saved per year per toilet. A home with 2.5 bathrooms saves $100 to $175 annually. Over 10 years, $1,000 to $1,750 in avoided water costs from a 5-minute adjustment. But plumbers profit from service calls addressing problems that high flush volumes exacerbate. Flappers wear out faster when subjected to larger water flows. Fill valves cycle more water and fail sooner. Higher flows can worsen partial clogs that lower flows would clear or prevent entirely by reducing the volume of water trying to force waste through restricted pipes. A population running maximum flush volumes generates more billable work than a population using optimized reduced volumes. Here's exactly how you reduce flush volume starting in the next 10 minutes. Remove the toilet tank lid and set it aside carefully. Locate the float mechanism. If you have a ball float on a metal arm, find the adjustment screw where the arm connects to the fill valve. Turn this screw counterclockwise to lower the float position, which will reduce the tank fill level. If you have a cylindrical float on the fill valve shaft, locate the adjustment clip or screw on the float itself. Slide or adjust the float downward by 1 to 2 inches, flush the toilet, and watch the tank refill. The water should stop rising when it reaches approximately 1/2 to 1 inch below the top of the overflow tube. If it rises higher, adjust the float down further. If it stops too low, adjust slightly upward. Once adjusted, test flush performance. Place several sheets of toilet paper in the bowl and flush. The waste should clear completely with good swirling action and bowl refill. If performance seems weak, raise the float slightly to increase volume. The goal is finding the minimum water level that provides reliable clearing. Most toilets work perfectly well with tank levels 2 inches lower than factory settings. Some can go lower. Experiment to find your toilet's optimal level. Each quarter-inch reduction in tank level saves approximately 100 gallons per year. A 2-inch reduction saves 800 to 1,000 gallons annually per toilet. For toilets without adjustable floats, use the displacement method. Fill a half-gallon plastic bottle with water and place it in the tank away from moving parts. This displaces half a gallon, reducing flush volume by that amount without any mechanical adjustment. Some people use bricks for displacement, but bricks can deteriorate and damage flush mechanisms. Use sealed plastic containers instead. A half-gallon displacement on a toilet flushing 25 times daily saves 4,500 gallons annually. At $8 per 1,000 gallons, that is $36 saved per year from a water bottle. The impact appears on your next water bill. A household in Arizona adjusted floats on 3 toilets, reducing tank levels by approximately 1.5 inches each. Previous quarterly water bills averaged $230. After adjustment, bills dropped to $195. $35 quarterly savings equals $140 annually from 15 minutes of work across 3 toilets. Over the 15-year remaining lifespan of those toilets, $2,100 saved from adjustments costing nothing. Combine flush volume reduction with behavioral changes for compounded savings. Do not flush unnecessarily. The mantra, if it is yellow, let it mellow. If it is brown, flush it down reduces flushes by 30 to 50% in some households. A family that flushes 28 times daily could drop to 18 by skipping flushes after liquid-only use. Each eliminated flush saves 1.6 to 3 gallons, depending on toilet type. 10 fewer daily flushes saves 7,300 gallons annually, adding another $40 to $70 in savings beyond volume reduction. Fix leaks immediately. A running toilet can waste 200 gallons daily, over 70,000 gallons annually, costing $400 to $700 in wasted water. Most leaks are flapper failures, costing $5 to $10 to replace. Check for leaks by adding food coloring to the tank. If color appears in the bowl without flushing, the flapper is leaking. Replace it immediately. Check toilet installation. Ensure the tank sits level and all connections are tight. A rocking toilet or loose tank can cause premature seal failures and leaks. Consider dual flush conversion kits for older toilets. These kits cost $30 to $60 and install in 30 minutes, converting standard single flush toilets to dual flush with separate buttons for liquid waste at 0.8 gallons and solid waste at 1.6 gallons. Average household water use drops 30% after dual flush installation. A $50 kit saves $60 to $90 annually at typical rates, paying for itself in 8 to 12 months. Install high-efficiency toilets when replacing old units. Modern WaterSense labeled toilets use 1.28 gallons per flush or less, while maintaining superior performance through better bowl design and flush valve engineering. Replacing a 7-gallon per flush toilet from the 1980s with a 1.28-gallon model saves over 40,000 gallons annually for a family of 4. At $8 per 1,000 gallons, that is $320 saved yearly. Toilets cost $200 to $400 installed. Payback occurs in 18 months, after which savings continue for the toilet's 20 to 25-year lifespan. Apply for utility rebates. Many water districts offer $50 to $200 rebates for high-efficiency toilet installation. Some provide free toilet replacement for low-income households or in severe drought areas. Check your local water utility website for available programs. Rebates can cover 50 to 100% of new toilet costs, making upgrades essentially free while delivering immediate ongoing savings. The knowledge exists in water conservation literature and utility education programs, but never reaches mainstream awareness because distribution serves no commercial interest. Plumbers profit from maximum water flow generating wear and service calls. Toilet manufacturers profit from selling premium models rather than teaching customers to optimize existing units. Utilities in some regions profit from higher water sales, though progressive districts now emphasize conservation. Your financial interest in reducing water waste opposes multiple industry participants who benefit from maximum consumption and frequent equipment failure. If this just revealed $40 to $140 in annual savings from a 5-minute float adjustment, share it with someone whose water bills have climbed steadily as rate increases compound with wasteful flush volumes. Every person who optimizes toilet water use is one less household subsidizing inefficient factory settings designed for liability protection rather than conservation. Every gallon not flushed unnecessarily is permanent savings requiring zero ongoing effort after initial adjustment. The next suppressed water saving method addresses showerhead flow restrictors that cost nothing to install and cut hot water heating costs by 30% while maintaining pressure through aerator design that utilities and heater manufacturers desperately need you to never discover.